In this lesson, we are mastering polynomial division, a fundamental technique for the Cambridge International A-Level Mathematics, 9,709 Pure Mathematics, 3 syllabus. You will learn how to systematically divide higher-degree polynomials and how to interpret the results using the division algorithm. This topic is essential for simplifying complex algebraic fractions and is a prerequisite for more advanced calculus and partial fractions often found in the P3 examination. In Cambridge P3, we define the division algorithm, where P of x is the dividend, D of x is the divisor, Q of x is the remainder. A critical rule for your exams is that the degree of the remainder must be strictly less than the degree of the divisor. If you divide by a linear factor, your remainder will be a simple constant. However, if you divide by a quadratic, your remainder could be a linear expression, like px plus q. Let's look at the two most important shortcuts for division by linear factors: the remainder and factor theorems. The remainder theorem states that if you divide a polynomial by a linear term x minus c, you don't actually need to perform the full division to find the remainder, you simply evaluate the polynomial at c. The factor theorem is a special case of this. If the remainder p of c is 0, then x minus c is a factor of the polynomial. This is the primary method you will use in your exams to begin factorizing cubic or quartic equations. Let us apply algebraic long division to divide a cubic polynomial by a quadratic divisor. We want to divide p of x equals 2x cubed minus 5x squared plus 4x minus 7 by d of x equals x squared minus 2x plus 1. Step 1. Divide the leading term of the dividend by the leading term of the divisor. 2x cubed divided by x squared gives us 2x. This is the first term of our quotient. Step 2. Multiply this new term by the entire divisor. We get 2x cubed minus 4x squared plus 2x. Now, subtract this result from our original polynomial. Be very careful with your signs here. Negative 5x squared minus negative 4x squared becomes negative x squared. Step 3. Repeat the process with our new leading term, negative x squared. Negative x squared divided by x squared is negative 1. Multiply negative 1 by the divisor to get negative x squared plus 2x minus 1. Finally, subtract this from our remaining expression. The terms in x cancel out, leaving us with a constant remainder of negative 6. Our division is complete because the degree of the remainder is less than the degree of the quadratic divisor. In the Cambridge P3 syllabus, you are often asked to consider the graphical behavior of rational functions. When we divide polynomials, the quotient actually describes the asymptotic behavior of the function. Notice the function we just divided. The quotient was 2x minus 1. Graphically, this represents a slant or oblique asymptote. As x becomes very large or very small, the remainder term becomes insignificant, and the curve approaches the line defined by the quotient. Whenever the degree of the numerator is exactly 1 higher than the degree of the denominator, the quotient will always be a linear equation representing this slant asymptote. Let's work through a typical Cambridge-style question. Find the quotient and remainder when, instead of standard long division, let's use a systematic algebraic approach to see how the quotient is built. First, we pull out x cubed times our divisor. This gives us the x to the power of 4 term, but introduces a negative 2 times cubed, so we must add 2 times cubed to keep the expression balanced. Next, we deal with that 2 times cubed by pulling out 2 times squared times the divisor. This adds a negative 4 times squared, so we balance it with a positive 4 times squared. Simplifying the middle terms gives us x squared. To get this from our divisor, we multiply by x. This introduces a negative 2 times, so we add 2 times to balance. Now we have 4 times remaining. We take 4 times our divisor, which gives us 4 times minus 8. To balance that negative 8, we add 8 at the end. By grouping the terms with the divisor, we see our result clearly. The quotient is x cubed plus 2 times squared plus x plus 4. And the remainder is 3. We can quickly verify this with the remainder theorem. P of 2 equals 16 minus 12 plus 4 minus 5, which is indeed 3. This consistency gives us confidence in our exam answer. In your exams, even small errors can cost you many marks. Let's look at how to avoid them. First, students often forget to include missing powers of x. If a polynomial jumps from x cubed to x, you must treat the x squared term as 0. In long division, if you do not align these columns, your subtraction will go wrong immediately. Second, sign errors are the most common cause of failure in this topic. When you subtract a negative term, it becomes addition. Always place your subtraction in brackets to ensure you distribute the negative sign to every term in the expression. Third, students often stop the division too early or too late. Remember our rule. You must continue dividing until the degree of the remainder is strictly less than the degree of the divisor. If you are dividing by a quadratic, your remainder can be linear, but it cannot be quadratic. To maximize your marks in the Pure Mathematics 3 exam, keep these professional tips in mind. Always use the remainder theorem to verify your long division. It only takes a few seconds to plug a value into your calculator, and it immediately confirms if your division was successful. If the values don't match, you know to go back and check your subtraction signs. If a question provides a graph of a rational function and asks for the equation of the slant asymptote, remember that this is simply the quotient from your division. You don't always need to perform a full algebraic derivation if you can identify the linear behavior as x approaches infinity. Before starting a long division to factorize a polynomial, check if the question says, show that x minus c is a factor. If it does, do not use long division first. Use the factor theorem to show p of c equals 0. This is much faster and is exactly what the examiners are looking for. Cambridge examiners often ask you to write the answer in the form q of x plus r of x over d of x. This is just another way of asking for the result of your division. Ensure you present your final answer exactly as the question specifies to secure the final accuracy mark.